Hello guys, myself Tushar and here we will discuss the topic about tree in the data structure.
Topics to be covered in this video: Introduction to tree, Introduction to linked list, Type of linked list, Example of linked list, Definition of tree with example, Key concept of tree, What is tree traversal, Code using C++ language, Real life example of tree, and conclusion. First one is Introduction to tree. A tree is a hierarchical data structure made up of nodes connected by edges starting from a single root node and branching out to child node. It commonly used to represent relationship like file system, database and organizational structure. But before starting it, we should take one overview on linked list. So what do you mean by linked list? A linked list is a can be defined as collection of objects called nodes that are randomly stored in the memory. A node contains two fields, that is data stored at a particular address and the pointer which contains the address of the next node in the memory. The last node of the list contains pointers to the null. Each node has two parts, that is data and next. Data stores the value while next points to the next node. Here is one example given below. As we see, there is one node having a data A and points to the next node, that is B. Then there are two types of linked list basically present in the data structure. One is singly and another one is doubly. Singly linked list. A singly linked list is a linear data structure where each node contains data and a pointers to a next node. It starts with a head node and ends with a node that points to null. Operations like insertion, deletion and searching can be performed, but traversal is done in one direction. It is flexible in size but does not allow quick access to random item like an array. For example, in the given example, there is a unidirectional linked list. So this can be known as a single linked list. Then another type is double linked list. A double linked list is a data structure where each node contains data and two pointers. One points to the next node and the other points to the previous node. These allow bidirectional traversing, making it more flexible than a single linked list. Through it required more memory for the additional pointer. For example, in this example we see one node, that is one having two pointers, that is previous and next. Previous points to the previous node and next points to the next node. Then we will start the main topic of this video, that is tree. So do you know what do you mean by a tree? A tree is a hierarchical data structure consisting of nodes connected by edges. It starts with a root node and branches into child node, with leaf node having no children. Trees are non-circular and connected, means there is only one path between any two nodes. They are commonly used to represent hierarchical relationship and optimize searching and data organization. Tree makes it easy to organize, search and manage data that has a hierarchical structure like file system on computer, organizational charts, decision making process and etc. Here is one example present of tree. So the example is the grandparent having a root node has a two children node, that is parent 1 and parent 2. Parent 1 has two child node, that is child 1 and child 2, while parent 2 has only one child node, that is parent 3. Then key concept of the tree. There are mainly 10 key concept of tree is present in a data structure. First is root node. The starting point of tree is called as root node. Then node, an element that holds data and may contain connect to another node is called a node. Parent node, a node that has one or more children node is called a parent node. Child node, a node connected to a parent node is called a child node. Leaf node, a node with no children at the end of tree is called leaf node. Edge, the connection between two nodes is called edge. Subtree, a smaller tree formed by a node and its descent is called a subtree. Level, the distance of a node from the root node is called as level. Height, the longest path from the root to the left is called height. Height means the longest path from the root to leaf is called height. Degree, the number of children a node has is called a degree. What is tree traversal? Tree traversal is a process of visiting each node in a tree's data structure in a systematic way to process or access its data. Traversal ensures that every node in a tree visit exactly once, and if it is often used to perform operation like searching, updating or printing the tree nodes. Types of tree traversal are pre-order, post-order and in-order. In pre-order traversal, it goes first to the root node, then goes to the left node and then to the right node. For example, as given below, it goes to the root node, that is 1, then its left node, that is 2, then left node is 4, and fourth right node is 5, then one's right node is 3. So after traversal it we get an answer 2, we get an answer 1, 2, 4, 5 and 3. So moving to the next type, in order traversal, first it goes to the left node, then goes to the root node and then goes to the right node. As example given below, it goes first to the left node, that is 4, then its root node, that is 2 and then its right node, that is 5. Then again 2 is the left node of 1, so after going to the 2 it goes to the root node, that is 1, and last one then it goes to the 3. So after traversing we get an answer 4, 2, 5, 1 and 3. After that, post order traversal is a process in which it goes to the first left node, then goes to right node and then goes to the root node. So as the same example we get the traversal answer is 4, 5, 2, 3 and 1. Then tree traversal code using C++. Real hash include IOStream using namespace yesterday, structure node, integer data, node left, node right, node in bracket integer value, data value, left null pointer, right null pointer, then below node print tree, node root. If root returns, say out root data inverted comma means it prints the current node. Okay, and then moving to next, print tree root left, print tree root right. So print tree in bracket root left, we can recursively print left subtree, and in next print tree in bracket root right, recursively print right subtree. Then integer main, for creating a simple tree manually, node root equal to new node, that is 1 in bracket, then root left equal to new node in bracket 2, root right equal to new node in bracket 3, root lefts equal to new node in bracket 4, then root left right equal to new node 5. So printing for that tree we will write cout and then tree traversal, then print tree in bracket root and then return 0. So here is a simple code for tree traversal, then we will run it and what's output it will give. Real life example of tree. First, file system. A tree structure where the root directory branches into folder like document, downloads and music with subfolder and files further branching out. Then second one is family tree, showing relationships starting with ancestor, that is grandparent, as the root and branching into parents and children. As we see in the image, grandparent is the root node, while parent 2 and parent 1 is the child node, while parent 2's children node is children 3 and children 4, and parent 1 child node is child 1 and child 2. Then moving to the next example, organizational chart represents hierarchical start with CEO of of the company at the root node and branching into managers and their representative employees. Then after that, moving to the conclusion of this video, tree and linked list are important data structure in computer science. Trees are used for organizing hierarchical data like file system. Linked lists are great for storing data in a sequence. Both helps in efficiently manage and accessing data. Here we end our lecture. So thank you and have a nice day.